Hey there, hope you're doing good. Let's work on this task. Fast writer should crop. So basically the concern is the fast video writer. Let's look at the diffs. I've already coded it up. This is an unrelated no op change, ignore this. This is also a no op change. This is a small change. So basically this replacement frame for function we have implemented. This replaces a frame before writing it to the video file. So basically I think I have to illustrate this in a sheet. Width, height and pixels. Photo resolution is 4032 times 3024. Let's make it megapixel. Okay, now typically when we talk about 4K video, it's Ultra HD, which is 3840 or 60. Now I am confused. 3840 by 2160. Which is 8 megapixels, right? The iPhone actually supports a max supported video resolution. This one is 4032 by 2056. Let's add one decimal place. I think it's the same thing. Yeah, almost the same megapixel. So basically yes, this is enough detail for us not to delve into the irrelevant. Typically if you take a 4K video using any device, it is this resolution, be it a standalone camera or a smartphone or anything. However, I like ultra wide videos where the width is more and the height is less. You see, instead of 2.1 it is 2.0 and instead of 3.8 it is 4.0, but the megapixels are the same. So basically the limitation is on the megapixels. Any hardware for playback supports a limited resolution and the limited resolution is in megapixels. So you can always trade off the width for the height. Now, so this is what I have done here, right? Old iPhone front camera 3088 by 2320. Which is 7 megapixels. So where does that leave us? In the time-lapse mode, we are cropping in both time-lapse and light trail video mode, which are the modes that capture a video. The input comes from the iPhone sensor at full resolution, 12 megapixel. So we need to somehow crop the width or the height to fit within the megapixel budget that we have. So how do we do that? In the light trail mode, we crop it to keep the same width, which is 4032, and reduce the height to 2056. This is what we use in light trail mode and time lapse mode for wide, tele, ultra wide cameras. In time lapse mode for front camera, this is all we have. Again, the older iPhones, the newer ones have 12 megapixel. So what do you do with this? You don't need to crop it anymore because it's already 7, which is lower than the 8 megapixels supported. So the logic is, when you are in light trail mode, you need to crop the 12 megapixel down to 8.2. You do that this way. When you are in time lapse mode, you calculate the height based on the width, and if necessary, front camera on old iPhones. If necessary, if it is a back camera or the front camera on the newer iPhones, then you crop it to fit this dimension. This is kind of tricky code. I coded this up before I started the video because I thought the details of the video resolution you would not be interested in. The time lapse mode should produce video files of a dynamical of different resolution based on which camera is being used. All right. Let's rename preview overlay to grid. So in any camera app, you see a grid on top of the viewfinder like this. See, this is the rule of thirds grid. This helps you compose your photos. So in photography, there is a rule of thirds which says that don't put the subject in the center, put them 1/3 of the way from the left or the right. And to help photographers implement this principle in their photography, this grid has been put in place. So you can place subjects relative to the grid. So you can see how the people are here. We have the same grid in our app. We call it preview overlay, but overlay can mean anything. If you are showing the ISO, that's an overlay. So we don't want it to be subjective, we want it to be precise. We'll just call it grid. Yeah, we shouldn't be editing these outside of Xcode. So basically the principle here is classes need to be named based on the domain. The domain is photography, and in photography this is what it is. So similarly, in insurance, you have different terms like a rider. What does a rider mean? It adds benefits or amends the terms of a policy. So riders are like add-ons. So when you buy a policy, you pay some premium for the policy. On top of that, you can buy a rider or two. So if you are building an insurance app, you should call it a rider, not an add-on. So you should use the correct terms as per the domain you are working in. Similarly, in photography, this is called a grid. It's not called an overlay. It is not called a photographer's aid. So let's use the correct name. And this is also very generic. It can be ISO, any kind of settings you see on top. Now let's look for void. Are there any places where we unnecessarily declared void? These are all callbacks, so you need a void. I don't think so. I was looking through some code and I suspected we were using void unnecessarily. I could be wrong, so I just wanted to check just in case. Yeah, these are all callbacks or completion handlers, as they are sometimes referred to. Yeah, you just have this weird. Yeah, this is the weird code I had seen. Okay. Yeah, there are no unnecessary calls to void. Let's look for lazy. Are we using lazy anywhere unnecessarily? This is very weird. You're creating a single filter options and then you're stuffing that into an array. Why on earth are you doing that? Drop downs. Okay. Yeah, you don't need to do this. Lazy initialization should be used only for something that has a side effect or is extremely demanding on the system's resources. Oops. This is used for lazy initialization, so we can't do anything about it. Yeah, we need to look at this weird drop downs. We don't even use them. Great. And this is not drop downs, it's drop down with only one. And you don't need a comment because the data type is drop down. Like, what else will it be? So now it can be let, I guess. That's also something we'll need to look at. These three we'll need to look for var and let. Okay. Futurecam label. Oops. We are not assigning. So one improvement leads to another. See, anyway when it is loaded the view is created, so the lazy initialization is not actually helping, it's adding overhead because it needs like a private boolean to check if it is initialized or not, so it's just overhead. Okay, benefits view controller is done. Main view burst counter. Okay, you are never assigning it. Let okay, main view is done. Before and image view too. Like logically these were always let, just that because of Swift limitations you can't do lazy let. Like logically the value does not change once it's initialized, so it should be a let, but because of implementation reasons within the compiler there's no lazy let. Okay, okay, what else can we do? Okay, this talks about if statements. Okay, there'll be hundreds. Oh no, there aren't that many. In fact, looking at the search will make you go crazy. It will be easier to just look through the code without using the search. None here. None here. None here. How can we change this to guard? So in general, the reason we are using guard is, so let me just explain the concept. So suppose you have a function in a bank called transfer money amount. You might write this statement: if amount equal to 0, return. Right? You can equivalently write this as amount guard amount greater than 0. I mean, assume it's an unsigned value, it can't be negative, so else return. And then you do the transfer here, the actual transfer of money. These are equivalent. Now, what's the difference, you may ask? The difference is, here if you have a guard, the compiler verifies that you return here. Suppose you forget the return here, it will be a runtime error. Here it will be a compile time error. Now, if there's one line, it's okay, but if there's a big amount of code, what's a good example here? It could have lot of nested cases. So suppose you rewrite this to if something then return. Now the compiler will complain that this guard has to return. It can't return only in some cases, it has to return in all cases. So that way the reader of this guard knows the overall control flow of this function. He doesn't need to read all this code, which may go to hundreds of lines. He just needs to know that from here on the data, the output is an AV capture video data output. Otherwise, we are returning. All this can be forgotten while reading the code. So that's why it helps. That's why I like using it. So now the thing is, if you want to change this to guard, you need to change it to not, which I don't like. So instead, let's try this. Should start session. We'll see, maybe this is not an improvement, in which case we'll revert it. Guard should start session, else return. Here should start session becomes false. Let's look at this diff. So basically, AV asset writer has a function start session. It is finicky to use because it must be invoked only once, otherwise it crashes. We have fixed that by making it ignore if called multiple times. So here, if you have already started, you are returning, otherwise you are starting and you are setting it to true. Now here we have changed it to the other way around. Should start session, you have initialized it to true, and you are guarding that you should start the session, otherwise you are returning. And again you are calling super and you are setting this to false. So the next time it will be guard false, so it will come here and return, same code. So I guess it's a marginal improvement. So let's move on. Buffered image. Here we have a guard. Some people have a different philosophy. They think guard should be used only for error handling. I don't have that point of view, I guess. It's just a tool. If it helps, use it. It's the same discussion that goes on with exception handling. Some people say it should be used only for exceptional situations. Some people say it should be used if it helps. So for example, in Python, to end a for loop, you throw a stop iteration exception. Some people say that's a really bad design. You shouldn't throw an exception every time to end a loop. You should throw it only if something really bad happened in the loop. Anyway, here the pool should be nil because you are creating the pool. You don't want to create it multiple times. Okay. You can even make it one line. There are no more ifs. Burst recorder. This is very tricky code. I loaded it with assertions. I am still not happy. I am not convinced. I don't know if this is the right design. I think I should use an explicit state machine, but that's something we'll talk about later. Okay, these are just to verify. This can't be converted to a guard because you are not returning. You are executing this code. It should not be in the stopped state for you to run this code. So the way you should read this is the condition that guards the code below. So before you add a buffer, you should not be in the stopped state. That's how you should read it. It's kind of split, but you should remember to put this else. So here you are asserting that there are some photos to save, otherwise you can't proceed. This is the saving code. If there's nothing to save, you won't save. Similarly, here you are guarding that the asset writer is not nil, otherwise you will crash. Here when you put the not, let's look at the diffs. I hope we didn't introduce any not, because I don't like negatives in if or guard statements. This is fine. Here greater than 0, here it should be not nil, which means we have an asset writer. Why don't we commit these changes here? These are good. We'll resume in the next video.